Hello, this is Julie Hester, and today I'm going to show you an introduction to Cisco switch configuration for CCNA networking. In this video, I'm going to discuss a few basics about switches, the types of configuration that we'll do on switches for housekeeping and IP addresses, how switch configuration files work, and scrubbing devices. First, I want to show you the Cisco Catalyst C1000 switch. This is a switch that you might find in a Cisco Networking Academy program. It's a basic layer 2 switch, and we can see 3 different types of ports on this switch. The left-hand side has a cable plugged into it, and this is the console port area. And that's how we will connect to the switch directly from our PC or laptop. The middle 24 ports are the ports that we'll use to connect to different devices inside our network. On this switch, these are gigabit ports, and so this switch can connect to 24 different switches or PCs or whatever types of devices we might have on our network. And then finally, over here on the right, these ports look a little bit different. They're rectangular ports because they use a different type of connector, an SFP connector that you probably won't see in an introductory course. Switches typically don't have an on-off switch, so what we can do is we can take a switch out of the box, plug it in, it will power up, we can plug a few devices in it, and we don't even have to do any configuration before that switch will start forwarding traffic. But this is a managed switch, and that does allow us to add additional configuration if we want to. Now, typically, when we have a new switch, we will do some basic housekeeping on the switch. And this is a list of the types of things we might configure. Now, in this video, I'm not going to give you the commands for each of these. That I'll show you in a different configuration demo video. But this is just a list of the types of things you want to know how to do, such as giving your switch a device name, setting a message of the day banner message. You may add basic passwords to your switch to protect it to different levels of access on your switch, such as user exec, privilege exec, and VTY lines. You may choose to do password encryption so that somebody can't look in your configuration files and see the passwords. We'll often disable DNS lookups. And then finally, we may set the system clock so that our switch has the same time as other devices on our network. Now, when we're working with our switch, there's 2 primary ways we're going to access the switch. The first way is called out-of-band access. And this is what you may do in a lab, where you're going to physically connect a PC to your switch through a cable and the console port. Now, the picture on the right, I've taken from the Cisco Introduction to Networks Lab 238. And in that example, the switch's console port is on the back of the switch. This is going to vary based on what particular switch you have. The C1000 switch I showed you a moment ago has the console port on the front. But for out-of-band access, you're going to physically connect your PC or laptop to that switch, and then you can use software like TerraTerm to show the terminal output on your laptop screen. That works when we're directly in a lab working with the device. But if you're in a production environment, and with a data center, you don't want to have to drive to the data center every time you want to modify your switch configuration. Instead, you're going to want to use something called in-band access. This allows you to access the device across the network, but be able to do so, the switch has to have an IP address so that you can locate the device on the network. And with in-band access, once the switch has an IP address, we can use a protocol like SSH to remotely connect to the switch and again see the terminal output on our own PC or laptop. So, how do we get an IP address on a switch? Well, here is the problem. Switches are layer 2 devices with physical ports that can't have IP addresses. Layer 2 devices don't have IP addresses. IP addresses go on layer 3 devices. So you may not know about layer 2 and 3 yet. But what you do want to know is, since we can't put an IP address on the port, we're going to use a workaround. And what we're going to do is create a virtual interface in software on a switch that's called SVI for Switch Virtual Interface. And this allows us to add an IP address to the switch on an interface for something called VLAN 1 so that we can be on our network and try to access this device. In this example, I've added IP address 192.168.1.5 to this switch. And now, if I'm elsewhere on the network, I can reach out to that address and access the switch. Switch will need one other thing besides the VLAN SVI address, and that's going to be a default gateway with the IP address of the router. So when you work on a lab, you'll probably be given that information as to what you need to put on your switch. With having these two items configured on your switch allows you to use in-band access to configure the switch remotely. So we've talked about a number of things that we might want to configure on our switch. How do the configuration files work? Well, when we turn on our switch, it's going to load what's called the startup configuration, and that is stored in something called NVRAM or non-volatile RAM. When the device is loaded, the operating system will locate that startup file and load the configuration that's stored there. However, as we're configuring our switch, all the changes that we make are stored in random access memory inside our switch. All changes that we make are made to the running configuration, and this is going to work kind of like if you were working with Microsoft Word and didn't have autosave. All of the changes are in memory on your computer, and that's fine, except what would happen if your computer lost power? Well, you would lose all of those changes unless you save them. So for our switch, we can make all the changes we want in the running configuration, but we need to save that configuration before we turn it off so that the next time the switch starts up, it can load our changes. And how we're going to do that is we're going to issue the copy running configuration startup configuration command, and that's going to take all those changes, save them into NVRAM so that the next time the switch turns on, it will load everything we've been doing. So in a production environment, I would certainly want to do that, but in a lab environment, we're often making changes, and we may want to start with a fresh switch. So we're going to do a process called scrubbing our devices. And that's going to be resetting our switch back to its basic settings like it was before we started. Kind of like a factory reboot. And how we're going to do this is we're going to go through a 3-step process where we first delete that startup file that we just saved by saying erase startup-config. Then we'll delete the VLAN database, which we may or may not have modified. And then finally, we can reload our switch, and it will reload the original startup file that doesn't have our changes. So when you do this, we actually want to do this to all devices before we start a lab and after we finish a lab. So why before the lab? Well, here's the thing. Sometimes somebody may be working in your lab and they don't scrub the device when they're finished. You turn on the switch, and if you don't realize their changes are still there, your switch may start doing things you don't expect because you have that other person's configuration on it. So we always want to scrub the device before we do the lab, and then of course clean up after ourselves after we finish the lab. All right, so now let's review what we've been talking about today. All right, I'm going to ask you a few questions about what we've been talking about. First, why does a switch need an IP address? Well, our switch needs an IP address so we can access it remotely through in-band access. Next, where are configuration changes stored? Well, until we save them, they are stored in the running configuration. Once we save them, then they are stored in the startup configuration file. What happens if a switch loses power before you save the running configuration? Well, you will end up losing all of your changes. They are not auto-saved on a switch. So if you don't save them, you'll lose what you're doing. And a good strategy can be to every 5 or 10 minutes or so, go ahead and save what you're doing so that if your switch does lose power, you won't lose your work or lose much of your work. And then finally, when should you scrub a device? In a lab environment, you should scrub your devices before you start a lab and after you finish your lab. All right, that's all I have for you today on beginning switch configuration. Now I'll look forward to helping you learn how to do the basic commands to perform housekeeping on a switch as we move through Introduction to Networks.